a sense of self. You know how, you know, it suddenly declares, I phone think, therefore I phone am. Should we? Oh my gosh! Well, you know, I better not switch it off tonight. So I think that's the challenge of consciousness is potentially one which, by its very nature, maybe is protective because I can't ever feel what it's like to be you. We all call this a red dice, but is your sense of red anything like mine? Pain. If you stub your toe, is that pain anything like mine? How can we actually quantify what it feels like to be you? We certainly got to a very exciting stage where, you know, it's a bit like being Galileo with a telescope. Suddenly the universe has opened up to him. We do have telescopes into the mind. We can actually see the activity of the mind at work and when it's asleep. And those tools have given us many things that we can tease out about consciousness. And it's interesting you mentioned Francis Crick, because Francis Crick, after doing DNA, consciousness was something no scientist could go anywhere near. It was regarded as something that you couldn't know. It was the domain of the philosophers and the theologians. But Francis Crick said, no, actually, maybe we can know much more about this. And the person I took on my journey to the edge of consciousness was actually this guy here, Christoph Koch, who worked with Francis Crick right at the beginning of his work on consciousness, when it was a very unfriendly thing to do. But the kind of insights we've got are beginning to give us some sort of idea of what it is about the network in the brain which might actually answer the question of consciousness. But actually, so I've met Christoph many times in America. I've had him over to Oxford to give talks. But my last interaction with him, we had a Skype call together where I kind of really pushed him. Okay, you might know all of these correlates of consciousness, but can you ever really know that something is conscious? And maybe that isn't unanswerable. And he got very angry with me, and he kind of shouted down the Skype call. Well, I assume it was him. Maybe it was an avatar that he uses to. But he said, what sort of research program is it, Marcus, where you throw up your hands and say, forget about it. I can't understand it ever. It's hopeless. That's defeatism. And I think actually it's the mindset of the scientists, and it's an important mindset, that we go into every challenge actually thinking there is nothing we cannot know. Thank you.
You have a distinction between something that doesn't exist and something we don't know.
extraordinary man. And it will be the purpose of this talk to pay due tribute to this man. And recall, as suggested by this title, that what he did was amazing, or to put it in the words of the great geometer Misha Gromov, speaking of an accomplishment of Nash, it could not be true, and it was true. Let's explain what Gromov meant by that. Here's a short biography of John Forbes Nash. Born in Virginia, he starts as an engineer at heart, studies chemistry, but eventually goes to mathematics. In 1948, he becomes a student in Princeton. 1949, 1950, he defends his PhD, including in particular the famous Nash equilibria. It's a two-page paper. From 1951 to 1958, he does a first-order, world-class mathematical career in MIT, Courant Institute in New York, and Princeton. And then he proves some theorems which are extraordinarily famous among analysts and geometers: embedding and continuity. 1959, a sad history of acute paranoid schizophrenia. And around 1990, spontaneous progressive healing. 1994, Nobel Prize in Economics. While lives in Princeton, this slide was written a few years ago, as I was for the first time lecturing on Nash. And later on, I will update this at the end of this talk. Here's a paradox. Maybe 95%, it's subjective measurement, of Nash's fame is due to game theory and his work on the so-called Nash equilibria. Famous in economics, famous in biology. But is that not, to use his own words, the least of his accomplishments? Should not Nash be thought of as one of the greatest analysts in this century? As Gromov said, he was combining extreme analytical power with geometric intuition. And the goals tonight is to focus on a less known story, less known than the game theory stuff, to ask ourselves what makes the value of a mathematical result, and to get behind the scene of a famous and dramatic paper of mathematical research. Let's get 60 years in the past, at the moment when young Nash arrives in Courant Institute. He's 28 years old. He's a, strongly built guy. He arrives in New York, and in New York he arrives in this already famous institute for advanced applied mathematics in some sense, Courant Institute. A place that after the Second World War has risen to extreme mathematical fame, and which is part of the world history of mathematics. As he arrives in Courant Institute, he's young, but already preceded by his legend. And Louis Nirenberg, one of the most important people in Courant Institute, has a problem for him. Hey, young Nash is coming, I know what I will ask. What was it that had made Nash famous already? Let's do a little bit of flashback and talk about that. What had made Nash famous was the so-called isometric embedding theorem. To motivate this, let us say that geometry can in several ways. Historically, geometry is measuring the Earth, or making a map of the world. We think of something which is two-dimensional, on a sheet of paper, thus draw the shape of the continents and the rivers and whatever. But as we understood, as ancient Greeks already understood, the Earth is not flat, the Earth is spherical. And as was first observed at the time of space exploration, you know, the 60s, the Earth is indeed round. And somehow that second view is simpler. The flat view is more complicated. Why more complicated? Well, you have all kinds of problems and paradoxes when you want to represent the world on a flat space. Problems of the shapes and, you know, the areas. If you look at the usual map of the world on a rectangle, like Antarctica, look like it's huge. And the countries in the center of Africa, they look small, while in fact they are huge, and Antarctica is not so big. It's distortion due to the flat representation. There are other problems. Interesting. This is a picture which I took some years ago in a hotel in Palestine. And as people who traveled in some places in the world in which dominating religion is Islam, when you arrive in a hotel, you always have this Qibla, that's an arrow indicating the direction of Mecca. Because if you're a good Muslim, that's the direction in which you should pray.